So what are we going to work on tonight?
I have some math mates I have to work on.
Okay. Stuff you can verbalize?
Yeah, most of it. Hold on, let me go get some lead for my pencil.
Okay.
Alright, so the first one is increase 65 by 80%.
Okay. How are we going to do that?
Multiply it by 0.80.
Okay. What do you get? You have a calculator there?
I actually don't. Mine died. It's charging.
Okay.
I think I could find one.
Do you have the TI-84 or the new Inspire?
The new Inspire?
The Inspire CX, CAS?
I think so.
That's a nifty calculator. All right. Well, I'm waiting for mine to load up here, and then I'll multiply that. Let's see. What is that? 46. So if I take 80% of 65, I get 46. Can that be the answer?
Say that again?
If I take 80% of 65, that is equal to the number 46.
Okay.
But their problem said what?
Increase 65 by 80%.
So what is my result?
The wrong answer.
So what do I need to do?
I'm not sure.
I need to add 46 to 65. In other words, when you say increase something by a certain amount, if I said increase 10 by 20%, you would take 20% of 10, which is 2, and you would add it to 10. So if I'm increasing 65 by 80%, I'm going to take 80% of 65 and add it to 65. Or alternatively, I could multiply it by 1.8 instead of 0.8. If I multiply it by 1.8, I get the answer immediately.
Okay.
Okay? So if I said increase something by 40%, what would you multiply it by? Increase 20 by 40%. What was it going to be equal to?
Would I multiply it by 1.4?
Yeah. And that would be equal to 28.
Okay.
All right. What's your next problem? What did you call these again? That's the second time I've heard that expression in the last couple of days, and only the second time.
Math mates?
Math mates.
Yeah, they're these worksheets that our teacher gives us every week, and they have like 32 questions on them.
Yeah. And this is the core stuff that you're supposed to get, right?
I guess. I mean,
They used to have a different name for them a couple of years ago. What did they used to be called? Wasn't mathmates. That's kind of clever if you think about it. It looks just like mathematics, doesn't it? Add an E and put that E there and add an IC and you got mathematics. Okay, what's the next one?
alright, it says simplify, and it's negative 15 TU in parentheses, and then divided by 5U.
Like that?
Yeah.
Okay. How can I simplify this?
Divide negative 15 and 5.
Okay, by what?
Just divide them.
Well, what I'm really doing is dividing the top by 5 and dividing the bottom by 5. In other words, this is a fraction. I can do only certain things to that fraction without changing its value. One of them is I can multiply it or divide it by 1. In this case, I'm going to divide it by the top by 5 and the bottom by 5.
Okay.
And that's going to leave minus 3 TU in the numerator and U in the denominator. So that's a good first step. Is there anything else I can do?
No.
What about the U's? The U's. Let's divide top and bottom by U. In other words, that cancels, leaving 1 behind.
Yeah.
So the greatest simplification is minus 3t. Okay?
Yeah, and then the next one says if y equals 2x minus 3 over x, find y when x equals 3.
Did I write that correctly?
Yes.
Okay, so what do we do here? This is basically the same as saying this. We have a function that's equal to that. And now I want to know what f of 3 is. What would the logical thing to do be?
Multiply it.
Plug in. Plug in 3 wherever you see x. In other words, when something is written f of x equals a bunch of variables involving x, and then you say, well, what is f of 3? Whatever's in the parentheses, I'm going to plug in for x. So that's 2 times 3 minus 3, all divided by 3. What's that answer?
Yeah. It would be 6 minus 3 over 3.
Which is 1. Yeah. So the answer is 1. The advantage of using f of x notation as opposed to y is that I can't really say, there's no real notation saying y of 3 equals. So that's why you'll sometimes see something called f of x instead of y, is because it allows you to be a little bit more robust. You can now substitute whatever you want in front of that. If I said, well, what is f of x squared? I would plug in x squared. So I would have 2x squared minus 3 all over x squared. So that's how the f of x notation works. And with y, you can do the same thing. They basically are saying plug in 3 for x and figure out what y is.
Okay. The next one is expand and simplify.
Okay.
It says 4 parentheses 2 VW plus 1 plus 3 parentheses VW minus 5.
Like that?
Yeah.
Okay. What's our first step going to be?
Distribute.
Okay. So what's our next line?
8 VW plus 4 plus 3 VW minus 15.
Now combine that. How many VWs do you have?
11.
How many numbers do you have?
Negative 11.
There's your answer.
Next one's an inequality.
Okay.
So it's x over 3 plus 4 less than or equal to 2.
Okay. First step.
Subtract 4.
Okay. So what's the next line?
3x.
X over 3? Is it x over 3 or 3x?
Yeah, it's x over 3.
Okay.
And then it's going to be less than or equal to 2. Oh no, that negative 2.
Okay. Next line.
You're going to have to divide, right?
Have to multiply both sides by 3.
Okay.
In other words, the left side, those 3's cancel, and I have just x. On the right side, I got minus 6. So there's your answer. The only time inequalities are different than an equation is when you have to multiply or divide, not subtract, but multiply and divide both sides by a negative number. You have to switch the direction of the inequality sign.
Okay.
In other words, let's solve the same problem, only I'm going to make one minor change. We'll make that a negative. So now, after the first step, you have this. Now, instead of multiplying both sides by 3, I have to multiply both sides by minus 3 in order to get x all by itself. And the moment I multiply both sides by minus 3, I got to change this so that it's the other way. Now, this becomes x because the minus times the minus becomes plus. The 3's cancel. So I get x over here, and I get greater than or equal to 6. So that's the only major difference in solving inequalities as opposed to solving equations.
Okay.
Do you get these math mates from an online site?
No, the school gives them to us.
Okay.
Just trying to find one that I can read that makes sense.
Okay. You can, if you like, take a picture of it with your smartphone and send it to my email, and then I'll pull it up on my screen and we'll both be reading it.
Okay.
If you want to do that,
What's your email?
I'll write it down. There it is. And you holler when you've sent it, and then I'll know when to look. You may or may not need to use your flash. If you take the picture in pretty good light, you don't need to use a flash. But if you don't have good light, the flash will help read it. What kind of phone do you have?
It's a Droid.
Okay. Do you know the megapixels on the camera?
No.
It's probably at least 5. You probably need it to be at least 5 for it to be legible. I think that's what mine is. Mine works pretty good. You have to hold it fairly steady when you take a picture, but you sent it yet?
Just about to.
Okay. I'll bet you your teacher gets those off of a website.
No, they come in a book.
Oh, yeah?
Mhm.
Okay. Just figured everything came on the internet now.
Okay, I just sent it.
You sent it to that address?
Yeah.
Well, While we're waiting to get it, why don't you verbalize one more?
Okay.
You put in the 1949?
Yeah.
Okay.
Alright, here's one. Coca-Cola uses 1.5 liters of water to make 1 liter of Coca-Cola. Express the difference in milliliters.
Coca-Cola uses 1.5 liters of water per 1 Coca-Cola?
Yeah.
Well, how many milliliters are in a liter?
I don't know.
The word milli means 1,000. So there are 1,000 milliliters in a liter.
Okay.
So if I multiply this, if I want to convert it, it's 1,000 milliliters per liter. And then the liters cancel, and I get 1,500 milliliters per Coke.
Okay.
I still didn't get that. I should keep reading some.
Alright, it says simplify. 3y to the 5th. It's in parentheses and then to the 2nd.
Like this?
Oh no, just the y to the 5th in the parentheses.
Okay. Like that?
Yeah.
So how do I handle something that is to an exponent and then being exponentiated further to a second exponent?
Wait, say that again?
When I have x raised to the b, all raised to the c, what does that equal to?
X, B, C.
Right. In other words, you multiply those exponents. So in this case, what is y to the 5th raised to the 2nd?
Y to the 10th.
Right. And the 3, nothing happens to it, so I bring it along. So that's 3y to the 10th. Notice that neither the 5 nor the 2 operate on the 3.
Okay.
Neither one of them. In other words, if I wanted them to, I would have to write it like this. And then the squared operates on the 3 also. So this would be 9y to the 10th if I put the parentheses in a different place. But as long as that 3 is outside the parentheses, then none of those exponents operate on it.
Okay, the ratio of molars to all teeth in healthy human adults is 3 to 8. If adults have 32 teeth, how many molars do adults have?
Okay? So the ratio is 3 molars per 8 teeth. In other words, for every 8 teeth in your mouth, you're going to have 3 molars. So if I had 32 teeth in my mouth, how do I solve this? 3 is to 8 as whatever we're looking for as an answer is to 32.
Okay.
How would I solve this equation?
Cross multiply.
I can do that, which gives me 96 equals 8x, and then the next step would be
Divide by 8.
yeah, but notice I can do all of that in one step. In other words, I don't need to fully cross multiply. Is all I need to do is just multiply both sides by 32. So multiply that by 32 and this by 32. The 32's cancel and I'm isolated my x immediately. And then I can solve this by dividing top and bottom by 4, or by 8, excuse me. So that becomes 4, that becomes 1. So I get 12 equal x. And that makes sense when you think about it. I have 4 times as many teeth as 8. 32 is 4 times 8. So the number of molars should be 4 times 3. Cross-multiplying works fine, it's just you notice that it adds one extra step. In other words, I didn't need to multiply both sides by the 8. I do need to multiply both sides by the 32, but then I have x fully defined and I just have to simplify whatever I have over on that side.
Okay.
Okay?
It says, hmm. It says using pi is equal to 22 over 7. Find the volume of the ice cream cone. The height of the cone is 70 millimeters, and the width of the cone at the very top opening is 30 millimeters.
Like that?
Yeah.
And I presume there's no cone in there.
Yeah.
In other words, there's no ice cream top.
Yeah.
Okay, so we need the volume of this cone. You remember the volume of a cone? The general formula?
No, I don't.
Okay, let's talk about a cone, but first let's talk about a right cylinder. A can. If this is a can of soup,
Yeah.
and it's 70 by 30, the volume of this can of soup is the area of the base, pi r squared, times the height. In other words, the volume of three-dimensional objects is always that are consistent from top to bottom, like a can of soup is always the area of the base times the height. Well, the moment you take that can of soup and shave off enough to be left with a cone, you have to shave off 2/3 of the material. So the volume for a can of soup is pi r squared times height. So the volume for just this part here is 1/3 of that. 1/3 pi r squared times height. And it's 1/3 whether it's a right cylinder or a square pyramid. In other words, if I have an object that is a square pyramid and goes up to a point, my volume is 1/3 of what a rectangular brick of that same height would be. In other words, if I had a brick instead of a pyramid, so the essence is that when you bring stuff to a point, you lose 2/3 of the volume. And that's a good way to remember the volume of pointed things. In other words, instead of the base times the height, it would be 1/3 of the base times the height. And it doesn't matter whether it's a pyramid or a cone or a 5-sided pyramid. You always lose 2/3 of the volume. So let's plug in everything we know here. So we're using this second one here because it's the volume of a cone. So let's plug in pi at the very end. So for the moment, let's leave it as pi. What's the radius?
It would be 15 squared, right?
Right. And what's the height?
70.
Okay. So this, I'm going to leave it in pi until the very final step, because most of the time you're not going to convert that pi. You're going to leave it as pi. Now, this can be simplified a little bit. You know how to tell if a number is divisible by 3? If its digits add to a number that is divisible by 3. In other words, 225 is divisible by 3 because these add up to 9, and 9 is divisible by 3. So 3 goes into that a total of 75 times. So now I have 75 pi times 70. And I could say that that is 525 pi. Multiplying the 70 times the 75, I get 5250. And now this would normally be your answer, 5250 pi. But since they want us to use 22/7 for pi, then I'm going to multiply that by 22/7. And whatever that number comes up to be is the answer. And actually it's a little easier if we go back to this spot and substitute 22/7, because the 7 goes into the 70 exactly 10 times. So now I know the answer is 10 times 22 times 75, whatever that number is. So you don't have to remember the formulas for geometric shapes, very many of them, but they do want you to remember the basic ones, like area of a circle, circumference of a circle, area of a sphere, volume of a sphere, volume of a right cylinder, cone, like that.
Yeah.
Those are basic stuff that they want you to know even when you take your SAT and your ACT.
Okay.
That's basically what I'm assuming MathMates is it's all of the fundamental math knowledge that they expect you to graduate with, as opposed to every single thing you're taught in geometry. You don't need every single thing you're taught in geometry. but you do need basic stuff to retain that. Okay, what else you got?
How many numbers are there from 10 to 99 in which the digits differ by 4?
How many numbers are there from 10 to 99 in which the digits differ by 4?
Yeah.
So they're looking for this. What's the last one going to be? Before 99.
95?
Well, it's got to be a multiple of 4. So I eventually get to 88, and then 92, and then 96. So all of these numbers right here, we want to add them all up. Well, how can I do that? I can take the difference. I can take 99 minus 10 and get 89 and divide that by 4 and get 22 with 1 remaining. And 22 is going to be right.
Okay.
The way to test the problem like that, because you can't really count up all 22 of them,
Yeah.
you could say, well, how many are there between 10 and 23? Well, I know how many there are. There's that one, and there's that one. So what formula do I have to use to come up with 3? Well, I got to take 23 minus 10, which gives you 13, and divide that by 4, and that gives you 3 with a remainder, and that remainder is between 22 and 23. But that's the answer. So the fact that we came up with 3 between these two numbers, where we can easily count them, that means the process that we're using between 10 and 99 is correct. Take 99 minus 10, divide by 4.
Okay.
If I said to you, have you ever worked with a spreadsheet?
Yeah.
How many rows are there between and including row 10 and row 99?
Wait, what's that?
How many rows are there if I open up a spreadsheet? Let me see if I can find a spreadsheet here about my high schools that I visit. If I wanted to know in Douglas County how many schools there are right here, that is, how many rows are there from row 34 to row 43?
9.
From 34 to 43. Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In other words, you can't just subtract them. You have to subtract them and add 1.
Okay.
If I said, how many rows are there between row 1 and row 2, how many are there?
3.
There's 2, right?
Oh, yeah, 2. Yeah.
Okay, and how did I get it? I took 2 minus 1 and added 1 to the result. In other words, this is a method where if I said, well, between row 34 and row 134, how many are there? That's too many for us to count if I had a spreadsheet. I wouldn't be able to do it. But if I know the formula is I take this number and I subtract that number and I add 1, I know the answer is 101 rows, including row 34 and row 134. In other words, including row 1 and row 2, there are a total of 2 rows. We have to subtract them and add 1. A little similar to that last problem, but a little more basic and fundamental, but a good one to know, because this is one you are going to run into frequently in life, is how many rows are there, or if 50 people are standing in line to get into a movie theater, and you're standing in the 3rd spot and somebody else is standing in the 48th spot, how many people are in between you? You're in a line to a movie theater. You're standing in the 3rd spot, and your friend is standing in the 48th spot. How many people are in between?
46.
In this case, because I said in between, not counting, then you have to take the difference and subtract 1. If you were in the 1st spot and your friend was in the 2nd spot, how many people would be in between you?
1.
0, right?
Yeah.
If you're in number 1 spot and your friend is in the 2nd spot, you're next to each other. So there's no people in between you. So I subtract the 2 numbers and then subtract another 1 to find the answer to that. That's the slightly different than saying how many rows are there from 3 to 48. This counts both the 3rd and the 48th row. So in this one you subtract the 2 numbers and add 1, but in this one you subtract the 2 numbers and subtract 1. Okay, what else you got?
Actually, I think that's it. I actually have to be to a hitting practice at 6.
Okay.
So
Keep your eye on the ball. I assume you meant a baseball hitting practice?
Yeah.
Yeah?
Yep.
Okay.
All right. Well, thank you.
I will talk to you next Tuesday.
Yep.
Okay. Bye-bye, Andy.
Bye.